Okay. Okay, guys. So hope you are doing great. And last week, if you remember, we have been discussing about some of the basic things in ROS, like launch file, ROS back, ROS RQT. We have seen some basics. And today's session is mostly hands-on. Okay, like we will be discussing different I mean aspects, like how to create row service, how to call those parameters, then how to create custom messages, how to create custom services. I will give you some examples. Okay, and sample codes basically. Okay, so you can refer that. Okay, mostly what I will do is if I want to do something, I will be like taking some examples and then understand it and then create my application. Okay, so that is the same approach that I am using here. I will be like talking about how we can do this, and I will give you some examples. So based on this, you can work on the projects. Okay, so after completing this programming hands-on, I think we can start with small projects. Okay, so that is the plan. So last week, if you remember correctly, we have discussed about the launch files. Okay, I hope you remember that. And launch files, I mentioned that it is a tool in ROS, basically to start multiple nodes in a single command. So for example, this is actually a launch file called learn_ros.launch. Okay, and the launch files are commonly keeping in a folder called launch. Okay, and it's a common convention. You can keep it in any folder, but in order to understand correctly, like launch file is keeping inside launch folder, and the extension of this file is .launch. Okay, so that is what you are seeing. Okay, and in this example, we are starting two nodes. So this is how we are starting two nodes, and I explained about this thing, which is actually we are starting the node as an anonymous node, meaning the name of the node will be changing. Okay, and we can run multiple instances of the same node at a time, and this is the no non-anonymous, that I'm not sure the correct usage, but these nodes is having a specific name. But if you use anon, means anonymous, so the name will not be, the name of the node will not be listener, it will be listener underscore something. Okay, and I was just testing, like this is how we can include a launch file inside a launch file. Okay, so here you can find, if you want to include a launch file called learn_ros.launch, you can just use this syntax. Okay, so maybe I can just give you an idea, like these are the things we have discussed, but I was just trying, like I was including the same launch file inside that launch file. Okay, so when this launch file start, it's again launch this launch file, so it's like a recursion. So that's why I tried before starting the class. So if you do that, like if you include the launch file in the same launch file, it will be throwing an error. Just a second. Okay, let me just comment this, and if you launch this, you will get an error like recursion error, maximum recursion depth reach, something like that. Okay, I was just testing, guys. So I can show you how to include a launch file inside a launch file. For example, I have a sample launch file called Docker listener. Okay, so when I execute, I will get this output from this launch file. Okay, so in order to include this launch file, what I have to do is I have to use this syntax basically. So it's like include file from the ROS CPP package from the launch folder. Just start the talker underscore listener dot launch. Okay, so this is how we can include a launch file inside a launch file. Okay, so this is a very useful thing, like when you work with big projects. So if you launch it, if you launch learn ROS, you can see it is also launching the included launch file. Okay, yeah, so I think that is about the launch file that we have discussed last class. If you didn't attend the last class, I will prefer you to check the videos, okay, recorded videos. Yeah, and also we have discussed about the ROS bag. Okay, maybe I can just, so if you just search about ROS bag, it is actually a tool in order to store the ROS topics. It's a very important concept in ROS, very useful. Basically, if you want to store the robot sensor data as a file, you can able to do that. So for a simple example, I can do a demo here. This is a hello world program, that is the talker and listener, and if you check the topics, we can see the chatter, right? Chatter is a topic, and if you want to store the value coming in chatter, we can see these are the values coming from the chatter topic, right? If you want to save it, okay, if you want to save it, then what we are using, ROS bag. Okay, ROS bag is a ROS tool in order to save the topics mainly. So record and then just mention the topic name. So it will start subscribing and it will be recording these value, current value. Okay, you can record for a long time. Only thing is, like when it records, it will consume the space. Okay, for example, if you record images and all, the size will be larger. So currently it's just a string data, so it will not take much space. Okay, so currently it is recording. I'm just canceling it, and then what I'm doing is I'm just going to play it. Okay, so I'm just closing the actual notes, and then I'm starting ROS code. Okay, and then I'm playing it. Okay, so you can find a bag file. The extension of the bag file is .bag, and I'm just playing it, and you can see it is started playing. Okay, and this is a total time duration that we have recorded. And if you check using ROS topic list, what you can find is here is the chatter topic. Okay, and if you echo the chatter topic, what you will get is the recorded values. Okay, so this is very helpful to record the robot sensor data like images, point cloud, odometry, all these things, and then you can use these for offline processing. So if you have the recorded data, then we can create our application based on the recorded data, so you don't need the actual hardware. Okay, so actually we have discussed the ROS bag in last class, so I was just refreshing the things that we have discussed. Okay, and I have also talked about the RVs and RQT, so maybe we can start with this RVs and RQT. I just gave a brief idea about it. I will give a detailed idea about these two tools because it's very useful, and then we can start with the programming part. Okay, so I hope you have heard about the RVs tool. Okay, so ROS is having two types of tool, command line tools and graphical tools. So RVs and RQTs are graphical tools. Okay, so in order to launch RVs, what you have to do is, obviously you can start the ROS code first and then just type RVs. Okay, RVs, that's it. So might be if you are working in VirtualBox or VMware, for some people you may get an error, like maybe related to graphics or something, just search about that error. Might be we can solve it using like downgrading OpenGL or something, but mostly the solution will be there. So if it is working well, then you can able to see this window. Okay, so this is ROS, very useful tool while working with robots. Okay, basically using the mouse, you can simply click it, okay, on the 3D viewport, and you can simply like drag it so you can see the viewport is also changing. Okay, so I'm going to explain the important aspects of ROS. Okay, so ROS is for visualization, and on the left side you can see a thing called displays. On right side there is a view, okay, a thing called view, and on the bottom there is a time, okay, time, and here there are some buttons, and here is some menus, right? So on the left side is the important part actually. So this is a visualization tool, right? So we can visualize or we can display different types of data. Okay, so here there is a button called add. Okay, so if you press this button, you can see what are the data that we can visualize on ROS now currently. Okay, we can expand it, we can add a different kind of display type, we can expand it by writing plugins, but these are the current data that we can able to visualize in ROS now. Okay, so we can visualize wide variety of sensor data like laser scan, then point cloud, then image. Okay, you can visualize image, then robot model, then yeah, so you can visualize a lot of things. Okay, and you can add the visualization display type, and then you can browse the topic. Okay, mostly the data, the sensor data is actually going through the topics, right? Like the drivers will publish the different kinds of sensor messages like laser scan, then odometry, all this type. So if you just check the ROS sensor messages, you can see wide variety of sensor data type available. So most of the sensor data type can be visualized using ROS. So here you can see image, IMU, laser scan, then point cloud. So most of the sensor related messages can be visualized in ROS. Okay, so here if you have any point cloud data, you can add a point cloud to display type and just browse for the topic. Currently there are no topics available, so I'm just removing it. Okay, and here is the important part. In ROS or in robotics, there will be a frame, right? The fixed frame. Like with respect to that frame only, the robot will be working. For example, if there is as a fixed frame, there will be a world frame. Okay, with respect to the world frame, there may be an odometry frame. With respect to the odometry frame, there may be base frame, that is a robot frame, like that. Or the world frame can be a map, and with respect to the map, there will be an odometry. And with respect to the odometry, there will be, so it's all related. Like we should have some reference, right? For like for navigation, we are using GPS, so GPS is the reference point. Okay, in robots, we will be mostly using maps as the reference point. Okay, so if you are working with autonomous robots or something, and if you are working with navigation, mostly map will be the fixed frame. Okay, with respect to that frame. But if you are simply working on a simulation robot which is publishing odometry, then odom will be the fixed frame. Okay, I will discuss about it. Okay, so what I'm trying to do is I will be running a simulation. Okay, and then I will be visualizing different data from that simulation. Okay, don't worry about the simulation, just check the topic data and its visualization. So I am planning to start an MIR robot simulation. So we will be seeing this simulation in the next chapter and all. Okay, so I'm just starting the simulation. So the use or the objective of starting the simulation is the simulation will be like publishing different sensor data. Okay, for example, in case of MAR robot, which is a warehouse robot, it is having 2 laser scanners on the corners. Okay, laser scan. So that is the main sensor, and also it is publishing odometry and all. Okay, so this is a simulation we have. So now can we just check the RQT graph? Okay, yeah, RQT, no, not now. So let me play with the ROS now. Okay, so for the fixed frame, if you just click here, you can able to see some frame. Okay, you can able to see some frame. So currently from the list you can find odom. Okay, so if there is an odom and if there is no map exist, then odom will be the base frame. Okay, so odom will be the fixed frame. Fixed frame means with respect to the odom, the robot will move. Odom will be starting from 0 0, and when the robot moves, yeah, Archit. Okay. So yeah, Archit, if you have question, please ask. Okay, I think he's not having any questions. Okay, so currently we are running the simulation, and let's see what are the frames of the robot. Okay, so we will be seeing RQT next after ROS, but maybe I can simply show you the transformation. Don't worry about it. This is our next topic, TF. If we are completing with the programming, we will be starting with TF. So here you can see with respect to the odom frame, we are explaining the base footprint and base link. Okay, so here the odom will be the base frame. I mean, not the base frame, fixed frame. Okay, so from the list you can easily identify odom or map will be the fixed frame, and then you can start adding the sensor data. So here there is 2 things, by display type and by topic. Okay, so these are the existing topics available and its type. Okay, so from this topic you can visualize all this data. Okay, this is the easier way. So you can see there is a laser scan topic, and there is IMU and all. Okay, so by the way, there is a question from Tejas. How do we know which is the first frame? Which is a fixed frame. So that is what I explained, Tejas. From the RQT we can able to find the base frame or fixed frame. So if you start RQT and if you load a plugin called TF tree, which is the next topic that we are going to discuss, so don't worry. So here you can see odom is the parent frame. With respect to the odom, all these things are described. Okay, with respect to the odom, how much distance is the base footprint and base link. Okay, I'm sure that you are not aware of the terminology, but just understand, just load TF tree and you can find the top one. So that will be the fixed frame. Okay, yeah, so the basis of selection of fixed frame is that, like, if you want to visualize any any sensor data or something, then you can visualize based on the parent frame. Then only we will get the exact transformation. Okay, so maybe while discussing TF we can get back to this, Tejas. That will be good, because I have to use some terminologies that is not familiar with. So now for the basic understanding, just understand that commonly we will be taking the parent frame. So with respect to that we will be visualizing. Okay, Okay, yes. So currently I'm planning to like visualize these data. Okay, so let me start with laser scan. Okay, so here there is a topic called scan, and I am visualizing it. And then so on the left side you can see laser scan is loaded with a topic scan. Okay, so scan is a topic and its type is laser scan. So maybe we can check it here. If you simply do the ROS topic list, you can find the scan topic here, and if you do ROS topic info scan, you can find the type is laser scan. Okay, so if it is a sensor message, from the sensor message, then you can able to visualize it in ROS. Okay, so here the visualization is happening. I'm not sure you can able to see or not. Maybe I can just add some modifiers into it. So the visualization, like I am just adding the size of the points. Now I think it is visible, right? It's a red arrow, I mean a red line, right? And yeah, it's actually like I mean there are some blinking here. I will explain that. So this is a laser scan visualization. Okay, I hope that is clear to you. And also we can add other stuff, like from the display type we can add the robot model. So the robot model is here. Okay, robot model here. Okay, so this is the visualization of the robot model. Okay, robot model is here, and we have something like transformation TF, which is a very important topic in ROS. So we can see the TF here. Then if you want to visualize some other things like odometry, I can add it. Okay, odometry, and I can just move the robot, and you can see the odometry data is that pointers. Okay, so whenever the robot moves, the odometry value increases like that. Okay, and also the scan data, you can see it is also expanding. Just a second. Okay, so it is not about the simulation and all, guys. It's just I mean I was just talking about the visualization part. So this is how the ROS works. Okay, so these kind of interactive cool visualization can be obtained from ROS. Okay, so you got an idea, right? So we can add different kind of sensor data to ROS, and this is the IMU visualization. Okay, so when the robot rotate, the IMU data will be changing. You can see there's a slight noise, but yeah. Okay, so like that, this is only having this much of sensors, laser scan and IMU. Yeah. Okay, so that is the add button or display box in ROS. Okay, so this is important one. And on the right side we have the views, camera views. Like I will prefer to put the camera views in orbit, so we can simply orbit the view. Okay, but there are options to like XY orbit or top down. So we will only get the top down view. Okay, the camera view is actually only the top down. So I am always using the orbit. So you can zoom it and you can just move like this. Okay, it's very flexible. Okay, so orbit is the type I think you can select, and this is for resetting the view. Okay, so if you just view like this, and if you want to reset the orbit view, you can just press the 0. Okay, so this is all related to the views. Okay, And also there is a ROS time elapsed, wall time. So this is useful when we work with the simulation. Okay, so like yeah, these timings are like useful while working with the simulations. Yeah, at that time I can explain that. So mainly understand this displays. Okay, displays is very important. And yeah, these are some buttons, like it will be useful while working with navigation. So there are some fixed buttons here, and the display type, and we can able to add some panels as well. Okay, so yeah, I mean that is not very important, but yeah, you can add some panels like this. Okay, and this RVS tool is completely written in Qt framework, Qt and ROS. Okay, so it's completely written in Qt, and you can expand the possibility of RVS by writing plugin. So here it's a teleop panel using RVS in RVS, and also we can, I mean, add different things to RVS by writing plugins. Okay, so yeah, so that's it. So I think initially you just need to understand the visualization aspect. Okay, after that we can see what are the things that we can do using RVS. Okay, I think you got a basic understanding of RVS, mainly for visualizing the sensor messages type data. Okay, you can visualize laser scanners, point cloud, IMU, odometry, robot model, all this stuff in RVS, and you can see the transform, all these things for visualization and debugging. Okay, so I'm just closing RVS, and I'm just going to the RQT, okay, which is again an interesting tool, again very useful tool. So let me close all this simulation. Okay, so in order to start RQT, you can if you have Linux or ROS installed, you can simply check RQT by first running ROS code, then just type RQT. Okay, just type RQT and enter. So you will get, mostly you will get a window like this, an empty window. Okay, so RQT, I will say it's a 2D visualization and debugging tool. Okay, and the RQT is having a list of plugins actually. So here is the list of plugins. Okay, so there are visualization plugin, there are logging plugin, then introspection plugin, all this stuff. Okay, mostly we use visualization plugins like TF3, image view, then node graph. Okay, these are very useful. So for example, I am just starting an example program, ROS-CPP tutorial stalker listener.launch and it is running. And in order to see the node graph, okay, node graph means a computation graph, you can simply load the node graph here. Okay, and you can see the computation graph. Okay, it's useful, right? And if you want to see the topic, yeah, the same thing. Okay, and if you want to close the plugin, you can simply take the running menu and close it. Okay, and yeah, and also if you want to monitor topics, okay, you can simply load that topic monitor, and you can see these topics that is currently active. Just click it and you can able to see the bandwidth, the heads it is publishing, and the data as well. You can see the data is hello world 559. Yeah, so you can see the data here. Okay, and you can close it. Yeah, so for accessing the logging data, we have the console. Okay, so here you can see the log information. Okay, so logging means there are different levels in logs. Like there are information, then for warning, for error, for fatal, or for debugging. Okay, so click if you want to exclude messages, you can simply click. For example, now we are only getting the info messages, right? So if you want to exclude info, then we will not get any info related messages. Okay, so the we have seen the ROS info function, right? ROS info. So ROS info is for, like, if you write a program and if you want to find some bugs, you will be using print statements, right? Print statement. So instead of that, in ROS we will be using ROS info, ROS one, ROS debug. Okay, so mainly we are using ROS debug for debugging purpose, and we can use that information to assess or to find any issues with the application. Okay, currently you can see this info is publishing, and then which node is publishing, and severity level, it's information only. Okay, yeah, so these are the this is a plugin for logging. Okay, and we can load multiple plugins in the same window. Okay, so that is again one thing. We can load multiple plugins. So there are let me check, is there any other interest? Yeah, there is a process monitor. Okay, so Karan is asking question. This is similar to command line, just GUI for the ROS. Yes, exactly, Karan. So all these things can be get from the command line, but this is just a GUI for, like, if you are not interested to work with command line, everything is there in GUI. Okay, and also another futuristic application with the RQT and RVC is that, imagine you are creating an industrial application, okay, industrial robot or something, and you have to design an HMI or GUI. Okay, so you can, anyway, so for some robotic application you need a front end, right? So one of the way to create front end is by writing RQT plugins. Okay, so simply you can load the RQT and load your front end plugin, so it will have all the buttons and everything. Okay, so that is again a good method for creating front end application. So RQT is another another way of creating GUI. You can create GUI in using any application, like web application or Android application, or anything will be fine, but we can use Qt RQT framework also to create front end. Okay, I have actually developed some plugin for some projects actually. Okay, so here is a process monitor. Okay, so you can see here the talker is actually using 1% CPU and 0.32 memory, but RQT is using a lot of CPU now. Okay, so yes, so it's basically because it is running the console plugin. Okay, you can see if I exclude this message, it is using less CPU. Okay, so you can simply experiment with these plugins. Okay, RQT. Let me show you some other visualization plugin. So for example, maybe I can just add my camera. Okay, and I can visualize it. Just a second. Okay, so what I'm trying to do is I'm just starting my camera driver. Okay, so there is a package called USB cam. I already installed it in my system, and then I'm starting the camera driver. So when I start the camera driver, it will publish a topic. Okay, these are the topics that is publishing by the camera driver, and this is the topic that is having, these two topics is having the image messages. You can able to see me, right? So this is the topic for the for images. Okay, so if you check that topic, if you simply info about that topic, you can see the type is sensor messages image. Okay, so it is a sensor message so that we can visualize in RVs and RQT, and it is publishing by a node called USB cam, which is the driver program, and which is also subscribing by the image view. Okay, so this is again an RQT plugin, okay, running along with that. So if you want to again visualize, just start RQT, then just close the existing plugin and then load the image view, and then you can see me, right? Okay, and you can maybe load another image view, load image raw again. Okay, so just understand, like, you can load multiple plugins, and if you want to visualize multiple images at the same time, you can do this. Okay, and at the same time, like, you can start RVs, and in RVs also we can able to visualize. So just add, and then here you can see this one. These are the topics by topics. Yeah, Karan, so Karan is having question. This is like creating multiple objects, right? Yeah. So we this is a plugin, right? So we can create multiple instances of that plugin. Okay, yes. And so I can load the image. So you can see here we can load an image in RVs as well. Okay, you can just visualize any number of images in RVs. It depends on the size, that's it. So again, I'm just adding the image. Okay, so you can see we are subscribing, I think 5 times. Maybe I can also show you the computational graph from the node graph. Okay, yeah, so this is what happening now, guys. We have yeah, so there is a question from Tejas. What happen if you load camera topic in RVs instead of image topic in RVs? If you load camera topic, okay, so you mean this, right? Adding camera and image topic, right? Yeah, so here there is an error, and you have to like care of the frame as well. So it is complaining that there is a type called camera, guys. So let me enable it. Okay, just a second. I think it got stuck because we are subscribing to image for like from 5 subscribers. So it seems like, okay, let me check. Let me try to disconnect and okay, it seems like stuck. Okay, so what I will do is I will do a restart and then just wait for some time. I think it's okay. Yeah. So we have been discussing about the ROS launch, ROS pack, RVs, and RQT. So I think the basic understanding of these tools is done. Okay. And I think, yeah, this is good for a start. But if we are discussing more into TF and all, it needs some understanding from this chapter as well. Okay, so we will be seeing the TF aspect maybe on the next chapter. Okay. Okay, so then we can start the programming part. Okay, programming exercises. So I actually included the programming programs that we are doing in the source code folder. Okay, so you can find this package called learn ROS from this folder. Okay, so I will be keeping all this code inside the source code, so you can use that. Okay, yeah, so the Ubuntu is rebooted, and now yeah, first maybe I can work on Tej's question. Just a second. So let me add the camera. Okay, and then I am starting the driver. And then I'm starting ROS. And I'm starting the camera. So it is complaining that for frame USB cam, oh, it's again, I think it's crashing. So basically the thing is, the message was you have to put the frame as USB cam. Okay, so that is a fixed frame for the image. So then you can able to visualize. Okay, so that is what the difference is. I mean, there is not much difference, like camera and image. Image will be simply visualize the image without checking the frame. Okay, but if you visualize using camera, it will be also checking the frame. Okay, because camera is publishing the topic with respect to a frame, right? There is a camera frame, and then camera is publishing with respect to that frame, right? And this camera frame is I mean, the camera frame is on the robot. Okay, so I mean, in that situation, I think maybe we can use this camera, but it's not very important, Tejas. It will be taking care of the frame. That's it. Okay, so now we can go to the programming part. We are just going to the workspace, and then this is the package that we have created, right? If you remember, we have created the talker and listener in CPP, and also talker and listener in Python, right? And we have created a launch file. Then we have I mean, we didn't edited the package.xml, right? So we have to clean up the package.xml, guys. Like you can just remove these commented thing. Okay, we have to, after creating a package, just clean up these things. Okay, so that will be good for you. And you can give the name of the package and for example, if I am the maintainer, I will give my name, Lyndon Joseph, and I will give my mail ID. Okay, so that is the standard practice. Yes, and you can put the license also if you want to open sources, then BSD. Okay, and if you are not using export tag, you can delete it. Okay, so this is the best practice. Just clean up the package.xml. So if somebody looks at your code, then they will feel like, yeah, you are maintaining it properly. Also for the CMake. Okay, I have just cleaned up the CMake, and you can able to see it's a very short CMake. Okay. So now I'm going to show you some packages. Okay, it is based on my book, so no need to worry. So first package is from this one. Okay, robot operating system for absolute beginners, second edition. Okay, so this is the, not this, chapter 4, yeah, chapter 5. Okay, so this is one package that we are going to see. Okay, and the next is from the Mastering ROS for robotic programming, third edition, and the chapter, yeah, chapter 2. Okay, so this one. Okay, so these are the two reference packages that we are going to see. The first package, that is from the robot operating system for absolute beginners. So this package is having the basic code, like we already seen, like talker and listener, and also there are some script for talker and listener, and also to interact with Turtlebot. Okay, not Turtlebot, Turtle Sim. Okay, we will be like working with this script. Okay, there is no C++ program, but only Python program for interacting with the Turtle Sim. And there is a launch file. I mean, yeah, that is the same launch file I think we have discussed. Okay, that is from this Hello World package. And from the Mastering ROS package, so this is again somewhat advanced. So this is having C++ programs. Okay, so these C++ programs are like, I mean, dedicated for custom ROS messages. So far we have discussed about like existing ROS messages, right? Like we have seen sensor messages, geometry messages, all this stuff. So what about creating your own message in ROS? Okay, not only message, what about creating a your own service? What about creating your own action? Okay, so all this template are actually included in this package, that is Mastering ROS demo package. Okay, so you might need this package, these two packages, to get started with your project. Okay, you can use this template. Okay, I think I need to clean up, but yeah, so you can use this, and maybe I will show you some demos using it. Okay, so first maybe we can start with the Hello World package. So I think I have already explained about the listener and talker. Now I am going to the script. Okay, so first start with some demos using Turtle Sim and programming. So I hope you familiar with the Turtle Sim thing. So like in order to start Turtle Sim, let me start ROS core. Then I'm starting Turtle Sim. Okay, so in order to avoid this, you can write a launch file. Like you can include the Turtle Sim in a launch file, and then yeah, so here is a Turtle Sim, right? So I will show you how to interact with Turtle Sim other than the command line tools. I think we have interacted with the Turtle Sim using the command line tools, right? Like we have published some topics, we call services, everything from command line. So now I am going to run some nodes. Okay, so first I will be running an executable or a code called move turtle. Okay, move turtle. Okay, 0.1. Okay, 0.10. So can you able to see the turtle moving? Right, the turtle is moving, and we are not using any command line tools or something. We are simply running a ROS node. Okay, and the turtle is moving. Okay, I'm just cancelling the code, and I'm giving 0.1 and 0.3. Can anyone say what is going on? Anyone say what is going on? like we have given 0.1 and 0.3, and then the robot start moving and it's rotating. Any idea, guys? What is this program doing? The move turtle? Any idea? Okay. Yes. So they're just saying, yeah, it is publishing of a topic. And yeah, Karan also saying direction and acceleration. Yeah, mostly. Like maybe first we can check the computation graph, right? So let me take RQT and then load the node graph. Okay. So guys, I think RQT, for working with RQT, there are two modes actually. You can start RQT and then load plugins, okay, or you can directly start the plugin. Okay, so for example, if you just type RQT and then just give an underscore, and then if you press the tab twice, you can see these plugins can be directly started. Okay, directly started. So RQT underscore graph, if you do, then you can able to see the node graph. Okay, so the node graph is the move turtle. Okay, our program is sending some topics. I mean, move turtle is publishing a topic and turtle sim is subscribing to it. Okay, so what is the topic that the move turtle is publishing? Move turtle is publishing turtle sim command velocity. Okay, so here the move turtle is actually publishing a topic called turtle1 command velocity, and then the turtle sim is subscribing to it, right? So we can see what is the move turtle is publishing. Okay, so in order to see, what you can do is you can simply echo it, turtle1 command velocity. Okay, so we are simply echoing or like subscribing to that topic and see what is happening. So you can see the move turtle, this node basically publishing linear velocity values as 0.1 and angular velocity as 0.3. Okay, and you can see the robot is rotating, meaning it is having linear and angular velocity. Okay, so that is what this node is doing. Okay, it is providing linear and angular velocity. So let's see what is inside this code. Okay, so we have ran the code, and now let's see what is inside this code. So move turtle I am just taking, and you can able to see this is the code. Okay, this is the code, Python code. Okay, I'm explaining Python code first because it's easy to understand, but make sure you work with the C++ as well. Okay, we will be seeing C++ code in the mastering ROS package anyway. Okay, so here can you understand what is going on? I mean, you already see the talker and listener program, right? And in the move turtle, what is actually happening? Maybe I can just give an idea. Okay, so the program start here, and basically it is calling a function called move turtle, which is here. Okay, and it is also accepting two values as command line argument. Okay, I think you know about the command line argument. If not, maybe I can explain. So when you run the move turtle node, you have to give the linear and angular velocity as a command line argument. Okay, otherwise you can I mean give write a fixed value here, but when I program, I just made it as a command line argument so that I can modify this value whenever I require. Okay, so if I give 0.2 and 0.3, and if I run, then the linear and angular velocity will be changing. Okay, so this is for convenience. Okay, So what happening in this program is, in the move turtle function, we are passing two values, linear and angular velocity. Okay, and that is going here. Okay, and inside this function we are starting a node called move turtle, and it is anonymous. Okay, so the name will be like move turtle underscore something, and we are creating a publisher, and the topic name is turtle1 command velocity. Okay, so this is the topic that turtle sim is subscribing. Okay, and what is the type of message? It's twist. Okay, so you can easily find out these things. So for example, if you just list out ROS node list, you can see turtle sim, right? So just check ROS node info turtle sim. So you will get the topics that turtle sim is subscribing. Okay, and the turtle sim is publishing. Okay, and also the services. So this is the topic that is subscribing by turtle sim. So if I do ROS topic info space command velocity, you will get geometry messages twist is the message type. Okay, and if you want to know about twist, just do ROS message show geometry underscore hash twist. So you can see in this twist message, okay, there are 6 fields, 3 field for linear velocity and 3 field for angular velocity. So the turtle sim is actually a 2D robot. It's moving in a plane, right? So we only have velocity linear x direction and angular is the direction, meaning linear movement and angular movement in x and z. Okay, so we only need to populate x and z value, x in linear, z in angular. Okay, so that is what it's doing here. Actually, in order to get the twist message, we are importing the twist message like this. Okay, ROSPy, it's already required for any node, any Python node, and this is how we are populating the twist message. Okay, so we got the linear and angular velocity here, right? So what I'm doing is I'm just creating a copy of the twist message like this. Okay, this is how we are creating a copy of twist message. So well will be the variable of twist. Maybe we can say it's a variable, and inside well there is a linear dot x. So that is what we can see here. Linear is the variable name. Inside that there is x, y and z. Angular is the variable name, and inside that there is x, y and z. So that's how we are working here, like well dot linear dot x, well dot angular dot x. Okay, so well dot, here from the message itself we can see linear dot linear dot x, angular dot x. Okay, so well dot linear dot x equal to linear velocity, well dot angular dot z is equal to angular velocity. Okay, so we just added the data into this twist message template. Okay, so inside this message we have added the data. So adding the data to a message is like you know how to write letters, right? So inside a letter inside a cover we are adding the letter and then we are sending. So this cover maybe we can say it as a message. Okay, ROS message, and inside that we have to add the actual letter, right? So that is what, like inside this message template we have to add the data. Okay, so we have to add the data, and then what happened, and we have to publish it. Okay, so when this node starts, this will be constantly publishing the twist message. Okay, so the difference between Talker and Move Turtle is that both the programs are publishers. Talker was publishing string message. Move Turtle was publishing twist message with to a topic called turtle1 command velocity. So just compare and understand. Okay, it's not a big deal. Only thing is I think we are actually sending topics to different topic name and different message type. Okay, so what you have to understand is, if you want to send a specific message, you have to like create a copy of it and then populate it with the data and then publish it. Okay, so this is actually the fundamental thing we have to understand while programming ROS nodes. Okay, how to populate, how to create a publisher, how to subscribe a topic, then how to create a copy of a message, service, action, and then add the data into it and publish into it. Okay, so this is move turtle program. Okay, so now I will explain one more program, which is move turtle get pose. Okay, move turtle get pose. So I will give a abstract idea. So I mentioned that the turtle sim will give the position. It will be publishing the position as a feedback. So let me reset the turtle sim. If you call reset, then the turtle sim will be like this. It will be resetting its position. And now I'm running the code, which code? The move turtle get pose. Okay, yeah. So ROS run hello world move turtle get pose, and then linear and angular velocity. Okay, so what you are seeing is the linear and angular we have given the linear velocity as 0.1 and angular velocity as 0.3, right? What we are seeing is the x and y value. Okay, whenever the robot moves, you can see the position of the robot. Currently it is only printing the x position, but there is y and y position as well. Okay, so this is a program. I can simply go through it, and then we will see in detail tomorrow. So Karan is asking a question. This is similar to running robot on ground, and there are other packages which can do it in air like drone. Yeah, actually, like we are running the robot, okay, and then we will get the odometry, right? So this is similar to that. Like we are moving the robot in a particular linear and angular velocity. So whenever the robot moves, in case of turtle sim, it is actually publishing the pose. Okay, I think you already know it. Maybe I can able to show you that if you are not remembering this. So there is a topic called turtle1 pose. Okay, so if you echo it, you can see the current pose of the turtle. Okay, current pose. And if you move the turtle, okay, turtle tilio, you can see these values are changing. Okay, so x, y, and theta values is the three values is for a 2D robot. Okay, you can see the values are changing. So imagine you have to drive the robot for 5 meters. Okay, so then you can simply simply check the position feedback, whether the robot reaches 5 meter or something. If it is 5 meter, then just stop, like that. Okay, so this is a important topic, that is a position value. Where is the robot now? Okay, the feedback of the robot, and based on it we can do a lot of stuff. Okay, like a feedback control. Okay, so if you want to move the turtle robot from here to here, then in order to move and in order to confirm that robot reached the goal position, we can use the pause. Okay, yes. So maybe I will explain the code tomorrow. Okay, so by that time I will be updating these packages into our repository. Okay, and you can just go through it. Okay, also this package. Okay, so I will be giving the Mastering ROS third edition as well. Okay, the book I will be updating. Maybe tomorrow I will be giving. So you can also check that. Okay, so now it's a time for Q&A. Let me know if you have any question in Move Turtle or the ROS tools or something that we have discussed today. Any questions? And also, like, you can start working on the project. I will not like give some fixed assignments for now. But I am also planning, like, if you are not having any idea what to do, like mainly I'm talking about the idea. So maybe if you don't have an idea, maybe I can propose some ideas in the discussion channel, so you can take that idea and implement. Okay, so I will be like thinking about some idea and I will be posting it. Okay, so you can use that idea and implement using ROS code. Okay, ROS code that is already there, like. Okay, so any question, guys? Any questions? I will say, like, you can start practicing. Okay, from the talker and listener and these things, you can start practicing, and then then only you will get a clarity. Any questions? Okay, I think if there is no questions, we can conclude for today, and tomorrow we will be continuing with this topic. So like I'm planning to like complete these things. Okay, we will be seeing different codes. Okay, we can't discuss all the code. What I will be doing is I will be giving an idea about some code, and over the time I think you will get an understanding. Okay, and then this is what we are like currently doing, like the ROS programming using TurtleSim. Okay, moving TurtleSim. Then we will be starting with ROS TF, which is one of the most important topic in ROS. Okay, ROS TF. Okay then, guys, I think that's it for today. See you tomorrow, and thanks for joining. Okay, good night everyone. Okay, bye.